Really? Oh, yeah? Okay, sorry, I didn't see you, yeah. Okay, then I'll continue in English. Yeah, all right? Yeah. All set? I'm being recorded, so I have, I'm being hung with microphones. I'm not sure what they all do, but as long as you can hear me, we're fine. So, welcome, my name is Bas Geerdink. I work at ING. I'm a team manager at the Customer Intelligence Department. Internet of Things, right? That's what we're here for. And probably you would not directly think about ING as a bank when we talk about Internet of Things, because we think about little small startups who are doing fancy stuff with Raspberry Pis and robots and other things. But who's been to the session this morning of Pim, my colleague? Okay, some. So you already know a bit what we are trying to accomplish and what some of our ambitions are. I will extend a little bit on that and try to get a little bit hands-on about what things that we could do with the Internet of Things. We are actually thinking a lot about it, but not only about the Internet of Things, but also all the things that concern that, and typically about data processing. So that's why I call the presentation Fast Data. We have big data, we have fast data. I'll tell some things about that. And we'll try to get a little bit hands-on with some technical stuff and some source code, if there's time. So let's see how that works out. Yeah, I just hope that things that you hear here, maybe you can bring them home and think about them in your own organization, because this is the way that ING is handling some things, and the way we are approaching it in a process way, in an architecture way. So maybe there's good things for you to take away at home. So first, Internet of Things. Well, I have to do a little bit with the hype, obviously, because else it would the presentation would be so very dull. But so I just went to Google and Googled what my competition is doing. And whoa, actually that's quite a lot, right? The Internet of Things is big, even in the banking industry. I've got some examples here. We have, actually there's the Bank of Things, right? Not the Internet of Things, the Bank of Things is there as well. So, and my colleagues from the Dutch Railways, I saw that they had a presentation, the Train of Things. So we probably have something of things always. So let's see how that works out. But there are some really good examples actually which the bank can do. And the last one is pretty good. That car over there contains a mobile ATM, so a mobile cash machine. And they call themselves, it's a bank in Poland, I didn't know what they are, but they have invented this machine that you can call for. And they bring you, same as Uber, they bring you a taxi, they bring you the car to get cash right at your doorstep, right? So that's actually quite a nice example of the Internet of Things. Connected cars with mobile GPS data and maybe other stuff that actually brings the bank together. And one of the nice things about working at a bank is that we have in some way a unique position, because the bank is the only place, not really maybe entirely true, but one of the only places where you can actually pay for stuff. So all the other connected things, yeah, they're nicely connected, but you have to go to the bank to pay it. And we get some competition because you can transfer money with Facebook and Google and stuff as well in the near future. Let's say that. But still, we have quite a good position there. So if we connect the bank to all the other connected things, that would actually be very, very great. Now, examples that you probably heard them this morning as well. Things we are thinking about is we connect the bank to the households, so you can actually pay for all the daily use of your energy, right? Why do we pay all this money up front and get it back in return and stuff like that? Why not just connect the bank to your gas meter, to your energy meter, and just pay on a daily basis, pay per use, and do it automatically? Or the other way around, there are also plenty of examples of that. People want to know more about what is happening with their bank accounts in a financial situation. So why not push alerts and events from the bank to the customers, which is you and me, and let them do with it whatever they want. If you want to know what your when your salary is coming in, for example, on your bank account, you can have it in a text. You can have it on your smartwatch. You can have the lights in your house blink up, red and green, whatever you want, right? So everything, a lot of things come together in the bank when we talk about the Internet of Things. And obviously, I have to mention one example, which is the prize-winning hackathon stuff that we did last year, the Google Glass. And some of the people are sitting in the audience who built that thing actually. What we did as an innovation concept, we designed a Google Glass app that lets you look inside a house when you want to purchase a first house. So another very nice concept. You don't actually look inside the house, obviously, but you're connected with your Google Glass to Funda and to Cadastre and to your bank account and your existing mortgage and your payment transaction and everything to see, okay, can I buy this house and what does it do for my financial situation? So that's typical examples that we think, okay, that's interesting for us. And oh yeah, by the way, this is one. I'm from the IT side a bit. Yeah, actually, I'm an IT guy. But our business, well, surprise, surprise, is also writing these reports. This is an ING report, which is all about the Internet of Things. So go ahead and read it. But this just makes some challenges, because this is probably, again, one of those disruptive technologies, especially for an enterprise, a large organization such as ING. We've already seen this before. This is the graph of who can make a guess, right? This is number of transactions. Anybody who can? You can see that the time is there and it's suddenly going up, way up. Yeah. Who said that? Yes. This is the mobile app. So you see what is the blue-gray graph of transactions, which is not accurate, but it's the sort of the correct position, because we saw the transactions at ING rising about 10% a year, so we could handle that pretty good in terms of what our IT systems had to do. But suddenly we got the mobile app, and with the mobile app, what do people do? They check their balance, not only not even more on a weekly basis, not even on a daily basis, but sometimes on an hourly basis. And also people make it, because the app made it very easy to pay for stuff, coming also with deel and with other payment methods, the transactions were almost increasing exponentially. So instead of 10% growth per year, we had 100% to 500% growth in the transactions per year, and we're still in that situation. And we had some problems with that as well, as you might know. But this is what happens when suddenly a movement pops up, such as the mobile industry, and maybe something like this can happen also with the Internet of Things. If we're really going to connect all these things to the bank, whoa, that means a lot, right, for our infrastructure, for our network, for our software. So that's why we are thinking about this. We started thinking about what is actually going on. And I work at the department now where it's called, the department's called Business Intelligence, Customer Intelligence, but basically what we are doing is we're trying to gather all data streams, all data in the bank, whether it is, as you can see, batch or real-time or something in between. And we made an investigation of how much data is actually coming in the bank, what actually do we want to do with it now and in the future. So we talked a lot with all kinds of business people, from marketing and sales to risk management to financial industry, whatever. And we made a plot of, what should we do in the future. And one of the things that was really interesting is that we don't do much real time actually yet. And real time is really real time with us, because real time is the time, for example, in between the moment that you pay a transaction and the moment it actually gets delivered, it actually gets effectuated. So that's maybe 1 second. Right? So if in 1 second we have to do a lot of things. And that gets even more interesting if we are connecting all those machines, whatever, things from the internet. What we did is we made a separation, big data and fast data. We used to have only big data, everything was big data, but now we have something else called fast data. And we thought, okay, but how do we want to, we are one department, we are one, we have one team of people who should be handling this. So wouldn't it be nice to actually be able to combine all these data flows, even though they have different characteristics, right? We have batch flows coming in like once a day, and people who are working at bank probably know all about this because this has been going on for 30 years already. Big files, flat files, which come and probably coming from mainframes, coming in once a day, which takes an hour to export, an hour to load and to process. But that's still actually very real this day. So that data is still very valuable, and there's been a lot of processing going on that. Online analytical processing, querying in terms of business intelligence processing and that kind of stuff is actually already very important for the bank. But what it would be nice if we can combine that with new real-time data flows, which are already coming in, and even in the future will be increasing a lot. In that way, we can do something like this. We can, and I made a diagram. This is the time that data goes back versus the number of customers of the number of instances. And I made two main types of analysis that you could do with this kind of data if you set this up properly. That's why this is important. When you see the yellow or orange diagonal line, so the line that goes across, that could be the analysis of the data of one customer back in time, all the way back in time, because that can be interesting. If a customer is doing something now on the internet, for example, or he's making a payment right now, how does that compare to what he's been doing in the past? That's actually what kind of analysis are very interesting, because we are one of the use cases that we were talking about next is fraud detection. So we want to know if a payment action, whether it is a bank transfer from one person to another, or an ideal transaction, or getting cash from an ATM, all connected in the Internet of Things, right? All coming together in the bank in 1 second. We have to determine on that instance, should we block it, or do we let it pass? Is it okay? And we are already doing some of that stuff, but very rudimentary. At least that's what I think, because they are all based on rules. For example, we have several countries. You can specify a list of countries. If you are transferring money to that country, I know, for example, Cuba is on the risk list, and some of those other things. Then it is probably not correct, and then the bank will signal it. They will call you up and they say, "Hey, what are you doing? Is it right?" So that is very rudimentary. It's based on business rules. But what if we can actually detect in your payment history the patterns of payments that you're making, and we can spot the irregularities? And that's what we want to accomplish with that kind of analytics, right? So if I'm a normal customer, I pay my bills, and I have a rent, and I get some salaries, and suddenly in the last, hour, I do some strange stuff because I buy a very expensive car, and then suddenly 20 or 30,000 euros gets written at my balance account, and then another strange transaction happens. Then, or maybe another example is I am always in 1 or 2 countries, and suddenly in one day I make transactions all over the world. that could mean that my account is hacked or there's something fraudulent going on. Okay. Another type of analytics that you could do, and if you set this up properly, is what we call the wisdom of the crowd. At least that's what I call it, but I don't know if it's like that. But that is more like the vertical analytics, and that's what you get when you combine all the data from the last minute or hour of all the population, of a segment of your population. And you could do interesting things with that. Also in fraud detection, because we have things that are actually very real, which is distributed attacks. Right, so people don't target one bank account, the hackers, but they will distribute their efforts. So if you see a sudden rise in certain types of transactions, for example, that could mean something. Or we can use it for promotional reasons or marketing. We could, for example, one of the things we are thinking about now is we have the segment of business users who are doing stock trades. And what if something happens, what's interesting for those people on the stock market, we will probably see a rise of stock, increased transactions in one area. For example, Philips or the entire Nasdaq or whatever. And we could do something with that data automatically. We could respond to it and say, okay, let's make it an alert for other people who are interested in this kind of data, for example. Or we can arrange the layout of our homepage based on, you know, the type of behavior that our customers are showing. Right. So we get a little more in depth. In fact, all the data stream doesn't matter what comes in, what goes out. It's actually following the same pattern, right? So it doesn't mean if it's slow, if it's fast, big, or small. We collect it, we store it, we process it, and we expose it, or we publish it. And I created a nice diagram for this already 1.5 years ago. We don't get into details with this because this is complex. But that is what this diagram actually is already saying. No matter what kind of data, you're probably, in this area of analytics, you're probably doing a number of pipes and filters, as they are called, in scientific architectural way. You're doing a process flow from left to right, you're doing some steps along the way, and you are just filling in the technologies based on the data flows, the type of data that you're using at the moment. So this is one of the, how do you say that, the principles and the practices that we are using at ING today, because we want to create one data lake, to introduce another hype term, where all data is coming in, no matter what kind of characteristics or what kind of speed it's coming in. We are not the only ones who invented this. This is, this is our own picture, but there's a guy called Nathan Marsh with a Z, and he is from Twitter, and he is the chief data architect there or something, or streaming analytics architect. And he created something called the Lambda Architecture. Don't know why it's called that, but that was on 2013. That was when the big data revolution was already started. But he was actually saying the same thing. He said, no matter what kind of type of data we are getting in our systems, we are processing it in sort of the same way, only we are choosing different kind of technologies based on the characteristics of the data. So, look it up, the Lambda architecture. It's actually maybe the most important reference architecture kind of things in this area, I think, at the moment. Now, we go a little bit into technology. We can choose what kind of technologies we will be using for this kind of data processing. And I just named a few, which I think right at the heart of the revolution. And we use these ones at ING. We picked some technologies which you think are cool and which our developers are eager to work with because it's so nice. Not entirely, but these, you just have to make a choice, right? So for big data and the batch processing, we used to have a lot of, and we still have a lot of old Oracle data warehouses, very big, terabytes of data. We're switching now to Hadoop, and Netezza. And Netezza, you know of it, it's a multi-core, multi-parallel processing application, or it's actually a box that you buy, so it's hardware and software combined, one of the fastest databases in the world. And Hadoop, you probably know, right? Hadoop, what is Hadoop? Database, maybe. Yeah. Actually, the last thing you said is most important, because Hadoop, and that's actually the primary reason that we are using it for, is a file system, primarily, right? They blew it up, to be honest, because now we have version 2.0 and we have frameworks all around it and stuff like that. But primarily, Hadoop is a distributed file system which is very efficient in storing massive amounts of data in files and getting it up again, so to say, and doing it in a very safe and consistent way. Well, we have Hortonworks as the technology vendor for that. And for event processing is something called, we chose Akka as a primary framework for that. I'll come to that in a minute. Because now we can go further, and I want to introduce Coral, the framework for real-time anomalies detection and other stuff. Because all the stuff about Hadoop, yeah, I can talk about that for an hour as well, but that's already in place, and we've been working the last 3 months, maybe 2 or 3 months, I guess, on a new framework for the real-time engine. Because, you know, based on all the things that we see happening in the Internet of Things, and based on actually the fact that we don't really have good technologies for that yet, there's a lot of focus now at the moment for getting that up. Right, so what we trying to do now is, based on the same principles of the Lambda architecture, we are setting up a technology stack, a framework for real-time analytics. And what should it do? Well, that's what it says here, right? Combine real-time events with customer data into a stream analytics API, yielding actionable events. And the most important thing about this thing that we are doing now, and also the most difficult, is we want it to be generic, because we talked about a few of these cases, of these scenarios. Fraud detection is one of the primary things. We talked about changing the layout of the homepage real time. All things that you can do within that second time frame that you have for a transaction. But we can think maybe of 100 things more, and we actually want to have a framework which is capable of handling it all. So instead of creating an application, we're creating a framework, with the first use case is probably the fraud analysis. So first concrete example is indeed the fraud detection. I talked about it already a bit, right? If data is coming in which you think is not good, so a normal person who has a mortgage of 200,000 euros and who has a car of 35,000 euros, but suddenly has a massive increase in transaction, and probably his account is hacked, or his PIN code is stolen, or whatever, or fraud is being done, or he is deliberately doing it himself, obviously, right? And you could ask, do people actually want the bank to see our data? Well, we don't actually see the data, because that's the nice thing about this. We only give a signal to a risk officer saying, hey, look, this guy, there's something wrong with the bank account at the moment that it happens. So that's not the case that everybody is looking at his payment transactions data. And as I said, we're already doing this in a rudimentary way, and we also seen, and that's almost in all the cases, that once we call the customer, they are always very happy that we are actually checking what is going on with their account, because we don't have it wrong often, And even if we have it wrong sometimes, then they still think, okay, yeah, it's good that you checked it because I was doing, yeah, some stuff which was out of the ordinary, so to say. Well, another opportunity, right, for our framework, the personalized marketing. I'll skip this one. Okay, then to our Akka framework. This is the high-level overview. Actually, not so. Akka consists of actors. Yeah, who knows Akka a bit? Okay, not so many people. Okay, I'll explain it a little bit. Akka is a framework based on Scala, although they released a .NET version as well. But what it does, it handles a lot of messy stuff for you for distributed computing. So it's based on actors, and actors are small packages of software. Think of them as services, which you can send messages to, and they are completely loosely coupled, and they run independent from each other. So that's the basic concept. But what the beauty of the Akka framework is that it handles, by default it's very scalable. So you can scale up, you can scale down. It's very fault tolerant. If an actor dies or something, it gets replaced by a new version if you want that.